Alright, hi everyone. So for this question, it says that by examining the potential maps for NH₃, NH₄+, and NH₂-, we can see that an atom with a formal charge does not always have a higher or lower electron density than the atoms in the molecule with no formal charges. So for part 1, it's asking us which atom carries the formal positive charge in NH₄+, and then part 2 is asking us which atom has the least electron density in NH₄+. So to start us off with part 1, let's go ahead and begin by drawing the Lewis structure for NH₄+. So our first step, if you recall, is to determine the total number of valence electrons in our chemical formula. Right? So nitrogen is going to have a total of 5, and each hydrogen is going to have 1. So that's 5 plus 4 is equal to 9, but we have to subtract 1 because of that positive charge. So minus 1 equals 8 valence electrons. So now what we do for our Lewis structure is we start off by drawing the atom with the highest bond preference in the middle, which in this case is hydrogen. And we start off by proposing a sigma bond framework, right? So that means that our remaining atoms, in this case our hydrogens, are going to be bonded to our nitrogen via 1 sigma bond each. So if we count our total number of electrons, we do in fact end up with the 8 valence electrons that we have for our Lewis structure. So now let's calculate the formal charge, which I'm going to abbreviate as FC on the screen. And our formal charge is equal to the number of valence electrons minus the number of non-bonding electrons. I almost spelled that wrong. Minus the number of non-bonding electrons minus the number of bonding electrons divided by 2. So if I scroll down to give myself some space, let's start off by drawing, or rather calculating, the formal charge of nitrogen. Right, so nitrogen here is going to be, our valence electrons is 5. We have 0 non-bonding electrons because we have 0 lone pairs. And we have 8 bonding electrons because our nitrogen participates in 4 single bonds. Right, so that's going to be 8 divided by 2. So that's going to equal 5 minus 4, which means that we have a positive charge of plus 1. Right, so for hydrogen has just 1 valence electron. We have 0 lone pairs, so that's 0 non-bonding electrons. And we have 2 bonding electrons because we have 1 sigma bond for each, divided by 2. Right, so that's 1 minus 1, which equals to 0. So for part 1, it's going to be nitrogen that carries the formal positive charge. So in blue on the side here, I'm going to go ahead and write that for part 1, the atom that carries the formal positive charge is going to be nitrogen. Now for part 2, it's asking us which atom has the least electron density in NH₄+. And we can look at that by noticing the colors of our electrostatic potential maps, right? So recall that in an electrostatic potential map, dark blue areas correspond to areas with more positive electrostatic potential, which means that we have less electron density, right? So if we look at the potential map for NH₄+ in the center here, our dark blue areas are actually concentrated around our hydrogens not our nitrogen in the center. Right? So because our hydrogens are in the dark blue areas of our potential map, they have the more positive electrostatic potential and therefore the least electron density. So for part 2, that's going to correspond to hydrogen having the least electron density. And this is going to correspond to option A within the multiple choice. So this is going to be your final answer. And with that being said, thank you very much for watching, and I hope you found this helpful.